Okay, so we'll start with this question first. See, question says that a chain of length L is placed on a smooth spherical surface of radius R with one of its ends fixed at the top of the surface. Okay, this is fixed here. Length of the chain is assumed to be L, that is less than pi r by 2. So see, this is here. Pi r by 2, this length is from here to here. This length is pi r by 2. Because no, if this is the circle, the circumference will be 2 pi r, half of that. So length would of the semicircle, I mean half of that circumference. So this length, and even like half of that, that will become this. So pi r by 2. So it means that this if this length is less than length of the chain, that is L, that is less than pi r by 2, it means that this end is not touching this uh, ground, right? So here we have to find the acceleration of each element of the chain when upper end is released. See, we have to apply the concept of, see, we'll cut an element. So take angle from vertical. So at theta angle, we'll uh, have an element. So theta and then d theta, this element will cut from this. So we'll first talk about this element and then we'll integrate it so that we can get uh, the result for complete chain, right? So this length would be from here to here. This length would be, this is very small element. So this length will be r d theta, theta equal to L by r. So r d theta. Now on this element, we'll draw the FBD. So one thing like sphere will apply the normal force on this element, that is like this, and one will be mg. Mg means what is the element of this mass of this element, that is dm, very small mass, into g. And dm will be, suppose the length of the chain is L, that is given, and mass of the chain is m, that is not given, so it will be cancelled out later. So the mass per unit length is this, and we have to find the mass for this length, that is r d theta. So this is dm. So this is equal to m by L into r into d theta into g. Now you can see that if you take component of this dmg, force due to gravity, so one component will be like this, and other component will be tangential. So you can see that if I draw the clear picture. So this is gravity dmg. This is normal, right? And this is a very small angle, so we'll consider this theta. So if this angle is theta, of course, this angle is going to be theta. So this angle is theta. Now, so this angle will be theta. So we have two component of this force due to gravity. That is dmg sine theta, and this is dmg cos theta. Now, you can see that this force will be balanced by this. Because, and this, you have to find the acceleration of each element. So this can be balanced by this. So n will be equal to dm into g cos theta, and because of this component, this will give you tangential force, right, along the tangent of the sphere. So because of that, we will get tangential acceleration. So tangential force is dmg sine theta. So dm is m by L into r d theta into g sine theta, and this is mass. No, not mass. So this is basically very small force. So force on this element. So let's call it dm, small amount of force. Now what we will do, we'll simply integrate it. We'll integrate this. So once you integrate, because also you have infinite number of elements. So df on
So
this,
what is so
sorry,
why did you write DFT, sir?
tangential. T stands for tangential.
Okay.
So you have infinite element. So df will be on each element. Df plus df plus df plus df plus df plus df plus. So it will sum up. Integration is sum of all the forces. So here from here you will get total force. That is m by L into r into g will come out. This is constant, and sine theta into d theta. Now theta will vary from 0. When this, if you Suppose now if this element is here, so theta will be 0, and the maximum angle of value of the theta will be somewhere here, because here this is not touching the ground, so we cannot take 90 degree, because it is saying that L is less than pi r by 2. So this complete angle will be, suppose this angle, so this angle will be theta equal to L by r. L means length of the chain upon r is the radius. So this angle will be L by r. Now we'll integrate this. So this is m by L into Rg, and the integration of sine theta is minus cos theta, and then upper limit and lower limit. If you want to consume this negative sign, this limit will change, so lower limit will become upper limit will become lower limit. So this will become cos theta 0 L by R. Now put the value m by L into R into G. Cos 0 is 1 and the cos L by R. So this is the net force on this chain. So if you want to find the acceleration of each element, you just have to divide
Sir, I don't
this
understand
one.
how you got the limits, sir.
Limit.
Limits for
See,
sine theta d theta.
let me draw this figure here. This is the sphere. This is the sphere. And chain is like, it is fixed over here, and from here to here chain till here only. So the maximum value of theta will be this much only, na? So this is the length, this is r. So this angle will be how much? Alpha. Theta equal to L by r, na? That is all. So if we take element at theta, so this theta will vary from 0 to maximum alpha, because after this there is no change here, na? Understood or not?
Yes, sir. Good.
Note it down.
सर हम उसको ऐसा घुमा सकते हैं क्या, माइनस कॉस थीटा को कॉस थीटा लिख के वो लिमिट्स को उल्टा करके?
इंटीग्रेशन में होता है वही सेम चीज होता है। तुम अगर नहीं भी घुमाओगे तब भी तुम लिमिट डाल दो तो माइनस बाहर आएगा, बाद में माइनस तो अंदर जाएगा, तो माइनस उल्टा कर देगा साइन को।
ठीक।
अच्छी समझ में आया?
सर अभी मैं इसकी वीडियो देख लूंगा एक बार, क्वेश्चन अभी पढ़ा नहीं ना मैंने।
अच्छा तुम अभी आया भैया?
यस सर।
हाँ देख लेना, अच्छा क्वेश्चन। नोटेड बालकों, बालिकाओं?
हाँ सर।
किसने नहाया नहीं क्या? तो वीडियो क्यों ऑन
हाँ
कर रहा है? नहाया हो तो वीडियो ऑन कर लो ना यार। चलो नेक्स्ट क्वेश्चन ट्राई कर लेते हैं। ये- अब रो तुम 2-4 मिनट रुको, क्योंकि मतलब आई विल टेक फ्यू क्वेश्चंस दैट यू हैव ऑलरेडी डन। उसके बाद फिर हम लोग आ जाएंगे सेम पेज पे। चलो जस्ट ट्राई दिस।
So will it be root of L minus H by 5?
How did you find so quickly?
So I just use S equals U plus AT, UT plus half AT square formula.
This is not a point object. This is chain, continuous object.
No, but sir, it still worked because S. But is that the answer, sir?
No, 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 madam, not at all, not at all. Okay, I'll tell. देवयानी तुम उस क्लास में नहीं थी क्या? मतलब 12th वाले क्लास में मॉर्निंग में प्रैक्टिस करवाता हूँ, उसमें ये सब करवाया था? नहीं
ये
नहीं क्या?
वाला लाइक आपने उसके बाद भी बताया।
ठीक है, ओके सुनो। तो क्वेश्चन सेज दैट ए यूनिफॉर्म चेन ऑफ लेंथ L is released from rest. This is kept on rest and some part is hanging, that is H. And find the time taken by the chain to slip off the table. Means this chain will completely slip off the table. Means like, you know, this end will come over here, something like that. So how much time it will take to come to, like, you know, for this length to come out, right? So do one thing. Uh, See, at any moment,
सर ये
this is your.
यूनिफॉर्म है तो हम इसमें इंटीग्रेट कर सकते हैं एक पार्ट का
Hmm,
सिर्फ।
hmm. So consider at any moment, some, like, you know, some part of this chain has come down, slipped. So at any moment, suppose x length is, this is the this is the length of the chain at any time t. At time t. So some part of this chain has slipped. So the total length is L. So length on the length of the chain on the table still is L minus x, right? Now do one thing. Just draw the FBD. See here. This is the point. If at this point you can see that tension will act upward and weight of this x length chain will act downward. So suppose mass of the length is L. So mass per unit lambda, if you define mass per unit length, is m by L. So what would be the length of mass of the chain of length x? That will be lambda into x, means m by L into x into g. So this is the weight of this length, right? Now see, this chain is going down with some acceleration. So net force is, so chain is going down. So net force has to be downward only. So m by
Sir,
L x
so
into
can you
g.
explain? So can you explain
But
the lambda part again?
lambda is mass per unit length, na? So m is the length of L.
Okay.
M is the length. Suppose, you know, 10 kg is the weight for 20 meter wire. So what would be the mass of the 1 meter wire? 1/10 of that, na?
Yeah.
Yeah. So that is, so m. This is the force equal to ma. Now, right now, for this chain, tension will be acting like this at this point. So, and mg will act downward, and table will also exert some normal force. So this normal and this mg will balance each other, and this, if this part is coming down with some acceleration, this part is also coming down with same acceleration. So this tension will cause this acceleration. So T is mass of this length, that is m by L into L minus x into acceleration. This is equation 1, this is equation 2. Understood? Everyone understood? So just add it. Tension will be cancelled. Now you can see that this is m by L into x into g equal to lambda. You can write m by L. This is x a plus m by L, L minus x into a. You can see that this and this will go gone, will be gone. Now m by L into L. So this is m into a, m and m will be gone. And from here you can say that a is g by L into x. Now a can be written as, because you have to find time, na? So just do this like dv upon dt. A is dv upon dt, rate of change of velocity. And
So,
yes, ma'am.
so after that equation, why did you write MA?
That is net force equal to mass into acceleration, na? Newton's
No,
second law.
no. So, like, how did you cancel it out, sir?
Just add these two equations, na? This is plus t, this is minus t.
Oh,
Solving simultaneous equation.
okay.
Now for this A, write this as dv upon, sorry, v dv upon dx. That is how we write acceleration. G by L into x. So v dv equal to g by L into x into dx. Now you integrate it. See, initially when x was h, right? Initial value of x was h, na? Because this h part was hanging at time t equal to 0. So at that moment, chain was at rest. So velocity was 0. At any moment, x part will be hanging. At that moment, the speed of the chain will be v. You just have to integrate this. So this is v square by 2. Put upper limit and lower limit. G by L. This is x square by 2. So put x by h. So this is v square by 2 equal to g by L. And this is x square minus h square by 2. This cancel. So v will be under root g by L into under root x square minus h square. Now, you have to find time. So for that, you have to again write v as dx by dt. So this is under root g by L. This is under root x square minus h square. So dx equal to under root g by L into under root x square minus h square into dt. Now again you have to integrate. Oh, no, this will come out because this is the function of x. Now, this is the function of x. So it will come this side, left side, dx by under root x square minus h square equal to under root g by L into dt. Again integrate. At t equal to 0, value of x was h. At time t, complete chain will slip. So value of x will be L, complete, right? So the integration of this is, you have to remember right now, this is ln x plus under root x square minus a square. That's it. So this is ln x plus under root x square minus h square, and then put upper limit and lower limit. This is under root g by L into integration of dt is t, upper limit t, this is 0. Put the upper limit ln L plus under root L square minus h square minus put h, this is ln h. H square minus h square 0, it will become 0. So this is under root g by L into t. So from here you can see that total time taken to slip completely from this will come this side, and this is ln a minus ln b. So ln a by b. So this is L plus under root L square minus h square upon h. So this is your answer. Understood? Note it down. देवयानी समझ में आया? खुद से कर लेगी ना?
हाँ सर,
लिख लिख लिया?
आप जैसे कर रहे तो मैं साथ में सॉल्व करूँ।
ठीक है। अर्चित समझ में आया?
यस
शाइना?
Okay, sir. Got it.
Did you
Yeah.
understand?
Yeah.
Okay. Note it down quickly. अब रो को तो समझ में आ ही गया होगा, अब रो तो पहले कर ही चुका है मेरे साथ एक बार। Noted, everyone? Noted? Okay. One more question, then we'll move ahead. Ah, this question I wanted to discuss. Just give it a try. Pretty much similar to the first question. समझ में आ रहा है? समझ में आ रहा है कि नहीं आ रहा? See, I'm just helping you. You have to break this chain into two parts. So see, from here to here, one part. And see, from here to here, na, this part is not in contact with this sphere. This is simply hanging. So after this point, na, chain will no more in contact with this sphere. So this is hanging. So you just have to take the weight only. So from here to here, you have to take element and need to do the same thing. So take element at theta. This will be d theta. So this length will be r d theta. So mass of this element is dm equal to m upon. So this length, see, uh, uniform flexible chain of length. So length is 1.5 meter and radius is this. So this length from here to here will be, so see 2 pi r means complete circumference. Half of that, so half of that, again half of this. So this will be the length from here to here only. So this, if you see 2 pi, 2 to gone, pi by 2 into r is 2 by pi. So this is what. So from here A to B, if A to C, if you see, AC will be how much? 1 meter. So CB will be how much? 0.5 meter. Right. So the mass of this CB will be mass of total length upon 1.5. See, M is the mass of the complete 1.5 meter length of the chain. So what would be the mass of this? That is 0.5. So M by 3. So this portion having mass M by 3. And this portion you have to do that thing. Take the element. Then you have to find that. Uh, so dm is mass upon total length into r d theta. Again, this is your same thing that we did in question number 1. dmg, and this is normal. And this is angle theta. So this is angle theta. So this is angle theta. So there will be two component of dmg sine theta, and this is dmg cos theta. So dmg cos theta and n will be balanced, and this will give you the total force. So that is how you have to find the force. That is df equal to dmg sine theta. dm is m upon 1.5 into r d theta into g into sine theta. Calculate the total force, that is integration df, right? And this is m will come out. This is 3 by 2. So 2 by 2 m by 3 r g integration sine theta d theta. Here theta will vary from 0 to 90 degree. 0 to 90 degree because chain is from here to C. And now if you solve it, you will get 2m rg by 3. Integration of sine is minus cos. And you just have to put this. You have to reverse this. 0 say pi by 2. If you put 0, cos 0 is 1, cos 90 is 0. So this is 2 mrg by 3. So this is the force on this part chain from A to C. And from C to B, only gravity will work. So net force will be, so total force will be this much, 2 mrg by 3, and plus gravity of this part, that is m by 3 into g. And put r is 2 by pi. So 2 by pi, right? So this is 4 mg by 3 pi plus m by 3 into g. So you have to find acceleration. So acceleration is total force upon mass. That is m will be gone. 4g upon 3 pi plus g by 3. This much. Understood? समझ में आया सबको?
Yes, sir.
Concept?
Yes, sir. So can you zoom in a little?
Let me know once noted.
So you took so for the limits for sine theta d theta, you took 90 to 0.
0 to 90. Lower to upper. 0 to 90.
Okay, 0 to 90.
As C, theta will be 0 for this element and theta will be 90 for this element. Because no, from
Oh,
0 to 90
yeah.
completely.
Yeah.
Done?
No, sir. Can you give us some more time? So for the total force part, after this first line, what is the second line, sir?
Where?
Is that R to the power of -1? 4 mg divided by 3.
Plus m by 3 into g. Weight
No,
of
no.
this part.
Before that, sir. 4 mg by 3.
Here,
Yeah.
3 pi.
So how did we get pi there?
R is, see, this R is given as 2 by pi here. Put this value.
Oh, okay. So can you go down a little bit? Yes, sir, done.
Everyone done?
Yes, sir.
Do this question now. ब्रो ये क्वेश्चन सर तुम्हारे लिए भी नया ही है ना? चलो फिर समझ में आ रहा है? How will you do it? अप्रो, समझ में आ रहा है कुछ? नहीं आ रहा है। और अर्चित?
नहीं आ रहा सर।
देवयानी को नहीं पूछूंगा, उसको आता है, मुझे पता है, शी इज इंटेलिजेंट। हाँ देवयानी?
कल ही बताया था।
हाँ, कल रात में तुमको बताया ही था मैंने। चाइना?
So I remember doing a similar question with you,
हाँ,
like,
similar question you asked me some time back, but that is a little different from this question. So let me tell you. See, saying that, like, you have this kind of frame, and U is moving horizontally, right? So do one thing. Just draw x-axis, and this is your y-axis, and U is moving along x-axis only, right? And this is y-axis. And see, it is saying that what is the speed of P when this SUT angle is 90, when this SUT is 90. If this angle will become 90, all angle will become 90, and like, this will become a square, right? Now you see, when this U will move towards right, P will fall as well as move towards right. Because, if you like, pull this U point, P will go down as well as along the x-axis. So P will have two components, Vx as well as Vy, correct? So at any moment, let's assume that this complete distance is x and this distance is y. So this distance is y, means from x-axis, distance of P is y. And this complete distance is x. So the half of this would be x by 2 and this would be x by 2. So if you take again this from here to this distance would be even half of x by 2. So this will be x by 4. Understood? Now you just apply this Pythagoras theorem in this triangle. In this triangle, apply the Pythagoras. So this distance is L. So L square can be written as x by 4 whole square plus y square. Correct? Now differentiate this. So L is constant become 0 and this is 2. This is x square by 6. Oh, wait, 1 point. Otherwise you will get confused. L square equal to x square by 16 plus y square. Now differentiate 0 equal to 1 by 16 into 2x into dx by dt plus 2y dy by dt, right? 2 gone. So you have x by 16 into dx by dt plus y into dy by dt equal to 0. Now see, what is dx by dt? So this complete distance, what is the velocity of u? That is 20 meter per second. Means rate of change of displacement. Na? So dx by dt is the velocity of u. That is 20. So that is 20. And what is x? When this SUT will become 90 degree. So this will become a square. So this L, this L. So this complete thing is root 2L and twice of this. So from here to here, it will become 2 root 2L. So x will become 2 root 2L. 2 root 2L, right? Upon 16. Now y is, what is y? So when this will become 90 degree, this y will be half of diagonal of this square. So diagonal length of the diagonal is L root 2L, half of that, L by root 2. And dy by dt, this is the rate of change of y. So y is decreasing. So this will be the velocity of P along y-axis. Because the rate of change of y is velocity of P along y-axis and y is decreasing. So this will be negative. So L gone. Now you can see that this is 2 root 2 upon 16 into 20 equal to Vy by root 2. This root 2 will go to this side. 2 into 2, 4. 4 4 is 4. This is 5. So Vy is 5. Now, what would be Vx? Vx would be rate of change of displacement of P along x-axis. So displacement of P along x-axis is x by 4. So 1 by 4 will come out and this is your dx by dt. So what is dx by dt? That is rate of change of position of u, that is 20. So this is, so now P has two velocity, 5 along x-axis, 5 along y-axis. So the net would be 5 root 2. So if you calculate, you will get approximately 7.1. Understood? Let me know if you have any doubt.
सर x की वैल्यू कैसे पुट करी हमने?
एक्स देखो ना, जब ये एंगल एस यू टी 90 हो जाएगा तब तो ये स्क्वायर हो जाएगा ना, जब स्क्वायर हो जाएगा तो ये एल, तो दिस विल बी डायगोनल, दैट इज √2l,
So how do
एंड
you
अच्छा ओके सर.
डबल ऑफ दैट इज कंप्लीट एक्स. हाँ, या चाइना.
so how did L square become 0 when you differentiate or sorry
बेटा,
integrate?
this is constant ना. If you differentiate constant term, that this is zero ना. Differentiation of any constant is zero ना.
Okay, okay.
Means differentiation is what do you understand by differentiation? Differentiation is the rate of change of anything, but that is constant, so there is no change ना.
Oh, oh yes, sir.
Note it down. Noted.
Yes sir.
Not yet, sir. 1 minute.
Okay. Next question.
Sir, 1 minute. Can you go back?
Okay. Okay.
Yes, sir. You can move.
Try this one. क्या बात समझ में आया? नहीं आया होगा? नहीं आया है समझ में? देखो बताता हूँ क्वेश्चन क्या कहता है. Question says that there is a lift. There is a lift. This lift is going up with some acceleration g by 2, and one very flexible uniform chain is hanging from the roof of the ceiling of the lift, and is just touching the floor of the lift, just touching the floor of the lift. It is saying that find the force exerted by the floor of the lift on the chain at the moment when 1/4 of the chain has already rested on the floor. So means total length is L. So L by 4 has already come on the floor. So see, two things will happen. So one will be gravity, because gravity means see. So if like of L by 4, some part of the chain will come to the floor of the lift. So this will become like on the floor of the lift, some chain will come, right? So you can see that gravity will work on this, and normal will work upward, right? So gravity will be, so see, if m is the mass of the total mass of length L, so m by 4 will be the mass of the length L by 4, and this is this mass into g. This is the force that Earth will apply on this part of the length L by 4, and this is normal. So normal will become equal to mg by 4. No, this is wrong, because length is also moving now. So G effective will be, relative acceleration will be 3G by 2. Because G is acting downward and lift is going up. So relative acceleration will be, you just have to reverse this G by 2 and add it to G. It will become 3G by 2. So this is 3G by 2. So total weight applied by gravity on L by 4 length is 3 mg by 8. So this force plus one more thing. You can see that chain is falling down to the floor. So there is a momentum change. If you look at the Newton's second law, how we derive force equal to rate of change of momentum, and momentum is mass into velocity. So two things can happen. If you apply chain rule, it will become m dv by dt plus v dm by dt. So earlier, like now, we ignored this because we kept mass constant. So differentiation of constant will be 0. So we ignored this. But in this case, we have to ignore this because chain is like falling on the floor with constant speed. So ignore this thing, and this force will become v dm by dt, because like chain is like chain will fall, will come to rest on the floor. So with time, like more chain will come and will be at rest on the floor of the lift. So more mass will accumulate on the floor of the lift, right now. So mass is varying. So suppose at any moment at any moment x length of the chain came down to the floor of the lift, x chain. So what is the lambda? That is mass per unit length. So what would be the mass of that x length? That is lambda into x. So m is the mass of length L. So what would be the mass of unit length? That is m by L. And what would be the mass of x length? That is m by L into x. So v, lambda will come out. This is constant, m by L. And dx by dt is what? That is velocity now. So v, m by L into v. So this is m by L into v squared. Now you have to find velocity of element. X is very small. X is very small. So suppose any element that is falling, right? Suppose this element will travel this x distance to reach to the floor. So what would be the velocity? Right now it is, suppose it is at rest. So v square equal to u square plus 2as. This is 0. So this is relative acceleration, that is 3g by 2 into s is x. So this gone. So v square is 3gx. So if you put here m by L into 3gx. So you can now see that total force would be this force because of momentum change, m by L into 3g into x is L by 4 in this case, plus this gravity, 3 mg by 8. If you add it, you will get 9 mg by 8. Understood? Now we'll move to constrained motion. Very important. नहीं समझा? हरजीत, सायना समझा?
Yes, sir.
अब्रो,
Yes, sir.
noted? Everyone noted? Okay. Now let's move to constrained motion. Constrained motion, or you can also call it constraint motion. Both are the same thing. See, as this name suggests, see, when two or more than two bodies are in motion, then motion of one body will depend on somehow they are interconnected with the motion of other body. Means motion of all the bodies have some mathematical relationship. Suppose one body is moving, suppose if I take a very simple example, okay, let me tell you a very important thing that I forgot actually. See, after that we'll start this. So see, suppose you have a pulley, massless pulley, and this pulley is fixed with the ceiling, and so this is hinge, and suppose there is a rope that is passing over the pulley, and this is one block is connected here like this on both the ends, and suppose m1 is more than m2, right? Now I want to find the acceleration of blocks. See, this is very basic thing, but what I want to tell you that you will definitely like it. So acceleration of blocks A and B. Suppose this is A and this is B, and okay, and then second thing is force. Hinge force. Suppose m is the mass of this pulley. I give you. Now you just have to draw the ABD. So this is the same string. So tensor will be same. And the string is ideal, non-extensible, right? No mass in a string. So this is tension. This is tension. This is M1G, and this is M2G. Now we know that M1 is heavier than M2. So M1 will fall and M2 will go up. Suppose A is the acceleration of M1. Now you can see this both the blocks are connected by the same string. So if M1 will fall with A acceleration, then definitely M2 will go with A acceleration up. Right. So now we have to find acceleration of the block. So see, so net force will be in for M1, net force has to be in downward direction. So M1G must be greater than T, then only it will come down. So right, net force is this, and that is equal to mass into acceleration, Newton's second law. And for this, E minus M2G equal to M2 into A. Just add it. You will get M1 minus M2 into G upon M1 plus M2 equal to it. So this is the expression that you need to remember. Otherwise, it does not take much time to calculate, but you need to remember, like, the acceleration of this mass pulley system is A1 M1 minus M2 upon M1 plus M2 into G. And what is the hinge force? C. So here tension will be T and here tension will be T. So on this pulley, if you draw the FBD of this pulley, 2T is acting downward. So this is the hinge that will apply normal force upward. This is hinge force. Because the pulley is fixed. So pulley is not in motion. So of course, like, a net force must be 0. So to balance this 2T, hinge will apply some force. So this N will be 2T. So just put value of A in any of the equation, you get T, and put T here, you will get hinge force, right? Now I wanted to tell you one thing. See, even if you suppose if you don't want to apply Newton's law of motion like this, you can also apply Newton's law of motion along the string. So in that way, you can get this result in one single step. How? See, applying Newton's law of motion along the string. How? See, this is the pulley. This is fixed somewhere. This is M1 and this is M2. Now, do not apply the Newton's law in horizontal direction or vertical direction. Just apply along the string. Suppose along the string I take anti-clockwise as positive and clockwise as negative. Understood? If you take anti-clockwise along the string, positive and clockwise negative. Now this is your complete system. String plus M1 plus M2 is complete system. So you can consider this as M1 connected with a string like this M2. Now, if this M1 will move to left, this will also move to left like that. So now see, M1 is heavier, so M1G will be heavier and M2G will be light. So net force will be M1G minus M2G. So net force is acting downward like this. So if you divide this by total mass of the system, you will get acceleration. Done. That is how you can apply the Newton's law of motion along this string. Understood? Everyone understood?
Yes, sir.
Okay.
Yes, sir.
Okay, note it down. Then I'll move to the constraint motion. Now, guys, put it. Everyone.
Yes, sir.
Okay, now let's move to constant motion. So we have three types of constant motion. First one is rod constant motion. Second is string constant motion. And third is wedge constant motion. Now, first I will talk about rod constant motion. Constant motion. So it says that length of the rod will be fixed, means constant. This length is not going to change. Now I'll make you understand from question. Let me take a question. This is wall. This is the ground. This is wall. This is ground. Suppose one rod is kept like this, and this rod will slide. This is point A. This is point A, and the length of the rod is given. So length of the rod will be constant. This rod will slide or is sliding. Suppose this end is moving with some velocity u. You have to find the velocity of this end. What would be the velocity of this end? Correct? Now, suppose method 1. At any moment time, at any moment t, let's assume that this distance is x and this distance is y. So use Pythagoras, x square plus y square equal to n square. Just differentiate this. 2x dx by dt, differentiation with respect to time. And this is 2y dy by dt, and L is constant because length has to be constant. So 2 and 2 cancel. And suppose this angle is when you have to find when the velocity of point A is u and you have to find the velocity of point B, at that moment it is making some angle theta. Now see, x is x, let it be x. Dx by dt, that is the rate of change of position of A, means u. And x is increasing. Dx by dt is the rate at which x is increasing because this is moving right. So this will be positive and that is u. Y is y. Dy by dt, rate of change of y. Y is y keeps on decreasing. So y is decreasing. So rate of change of y will be negative. So this is v equal to u. So v will be x by y into u, and now x by y can be given as cot theta. So this is u cot theta. So velocity will be u cot theta. Understood? But this is completely mathematics. I haven't applied any physics over here. So now in second method, I'll apply physics. See, this is the rod. So just break this velocity, break this speed into two components, one along the line, along the rod, and other along the line perpendicular to rod. So if this angle is theta, so this angle is theta. So this will be u sine theta, and this will be u cos theta. And if you break here, you will get this and this. So this angle theta, this angle 90 theta, so this angle theta. So this will be v cos theta and v sine theta. Now see, we are not bothered about the component which is perpendicular to this line, because the perpendicular component of the velocity always gives you rotational kind of thing, right? So now if you think that, see point A has this, u cos theta is trying to increase the length of AB. U cos theta is trying to increase the length of AB, and V sin theta is trying to decrease the length of AB. But as per the rod constraint, length should be fixed. Length can neither be increased nor be decreased. It means that velocity of approach and velocity of separation must be 0. It means that u cos theta must be equal to v sin theta. It means that v is u cos by sin, that is cot theta. This is physics and this is mathematics. Understood? Everyone understood? This is rod constant. Means the velocity of separation and velocity of approach must be 0 along the rod. Noted? Now, I want you guys to find the velocity of point C, whose coordinate is x by 2, comma, y by 2. Find velocity of C. Find velocity of point C. Done? हो गया सबका?
सर आंसर क्या है?
तुम्हारा क्या आया?
माइनस यू कॉट थीटा ऐसा कुछ।
हाँ ठीक ही लग रहा है। मैं बताता
माइनस
हूँ।
यू कॉट थीटा ठीक है।
Partially correct है। देखो, so C will have two velocity because now this rod will slide. So if this rod will slide, this end will go this way and this will fall. So C will have two velocity along x-axis as well as along y-axis, right? So velocity of C along x-axis would be d dx of rate of change of its position, and the velocity of y will be along y will be d dt of rate of position along y-axis. So half will come out, and dx by dt is what? U, na? Dx by dt is the rate of change of position of A, na? That is U. And this half will come out. Dy by dt is what? That is V. V is what? U cot theta. So the velocity of C would be vector Vxi plus V by j. So Vx is what? That is U by 2 along positive y, and this is downward. So this is minus U by 2 cot theta j. This is the velocity of C in vector form. Understood? सबको समझा? अर्चित, देवयानी, शाइना, you understood?
यस सर।
Yes, sir.
Yes, sir.
So, note it down. Bro. नोटेड।
फिर आज रात को केमिस्ट्री नहीं होगा ना?
नहीं, आज तो खाली फिजिक्स ही होगा। अभी मैं सरफेस केमिस्ट्री भी शुरू करूंगा, तो मैं प्लान बना रहा हूँ कि किस टाइम क्लास रखा। मैं सबसे बात करके ना सरफेस केमिस्ट्री भी स्टार्ट करना है मुझे, और ऑर्गेनिक में रिडक्शन ऑक्सीडेशन भी स्टार्ट करना है। बट निकाल लेता हूँ टाइम, कर लेते हैं प्लान। बट कल से पक्का करेंगे रात को, पर आज थोड़ा लेट काम हो गया actually। चलो, डन। नाउ विल मूव टू सेकेंड, दैट इज स्ट्रिंग कांस्टेंट। See, there are three assumptions that we need to consider. First, string can't break. Second thing, not extensible, means unextensible. Is it the correct word, English word? Non-extensible, unextensible, non-extensible, non-extensible. And third, can't slack, can't slack. See, one block is connected by a rope to another block. Now see one thing. Take a minute. Jao. Now you can see one thing, that this block A is connected to block B by a string. So see, if with respect to A, if if block B has some relative velocity with respect to A, it means that suppose B can go this way or this way. If B goes this way, see, I'm saying that B will have some relative velocity with respect to A. So A is at rest. Now B will move. So B, if so see, B can move like this. So in circular motion, B can do. On circular path, B can move. But if B moves in this way or this way, if B moves this way, rope will break, string will break, because A is at rest. Either a string will break or extend, right? That is not possible. That is against the assumption. And if B moves towards A, string will slack. That is against violating the assumption. So velocity of separation and the velocity of approach must be 0. Understood? Did you understand this concept? Hmm.
Sir, can you explain it again? I didn't understand.
In a string constraint, physics says that the string can't be slack, can't be extensible, can't be non-extensible. Sorry, can't be extensible, and it cannot break. So suppose A block A is kept at rest, and B is moving like in this direction. So if B will move in this direction, string will break. That will violate this assumption. And if B moves this way towards A, in that case, string will slack. So that is again the violation of this assumption. So that is not acceptable. So velocity of separation and velocity of approach has to be 0, because string can neither be slack nor be stretched. That's why.
सर
Okay,
तो
sir.
मूव नहीं करेगा कुछ?
मूव करेगा इस सर्कुलर पर क्या move?
ओके सर।
हम्म।
सर थर्ड पॉइंट क्या लिखा है आपने? कांट
Can't slack. See, I'm taking one question. With the help of that question, I'll make you understand how to do this. See, this is the spring pulley system. In this case, we have to find acceleration of 5 kg mass. You have to find acceleration of this. See, I will solve this in 2 ways. Okay, now method 1. See, first thing that you have to do is, see, I'm telling you this short trick first. See, summation t dot acceleration. This is vector quantity 0 or summation t dot velocity is 0. So this is like, you can say that work done on a string or work done by a string is 0, sum of all the. It means that if you can consider A as well as consider velocity, both. So how to apply this? I'm telling you. I'll explain the whole thing again. Later. First, I'll tell you the shortest way. See, you don't know which object will go up or down. So you just have to randomly assume. Suppose this block goes down with some acceleration A. This object will go up with some acceleration. This will go up with some acceleration C. I don't know whether my assumption is correct or not. Just randomly assume. Correct? Okay. Now, what you do is select the longest string. Select the longest string. So it looks like this string is the longest string. Correct? Now see, this is the longest string. So this is tension T. String is same, so tension will be same everywhere. This is T. So this is T. 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 Now you can see that in massless pulley, if this T and plus T, so this will become 2T. So this will become 2T. This is T. This is T. 2T. So this will become 2T. So this will become 2T. I have assigned the tension in all these strings. Now what I'll do, I'll just apply this because we are talking about acceleration now. So we'll apply this. See, on block this 10 kg, tension is upward and we have assumed acceleration upward. So how do you write dot product A dot B? This is A, B, and cos of angle between vector A and vector B. So tension is one vector, acceleration is other vector. So in this case, tension is upward, acceleration is upward. So what is the angle? 0. One moment. So you can see that tension is upward, acceleration is upward. So both in the same direction. So this will be tension into acceleration here, because these are the massless pulley. So we are not considering massless pulley. We'll consider about the block only. Here for this block, 2T is upward and acceleration is also upward. Same direction, angle 0. So 2T into B. And for this, you can see that block this, 2T is upward, A is down. So opposite direction. So minus 2T into A. T gone. So C plus 2B minus 2A equal to 0. This is called constraint relation. You can say that string constraint. String constraint. This is needed. Why this is needed? I'll tell you. See, now you draw FBD for this 10 kg. 10 kg means mg will work downward. So 10 into g, that is 100 Newton. It is also moving downward. So 100 Newton minus 2T equal to m into A. For this, 2T minus 5 into g, that is 50 Newton. So 5 into B. And for this, it is also moving upward. So T minus 10G equal to 10C. Now you can see that you have 3 equations and you have 4 variables, P, A, B, C. How? You cannot find this. Na? So just to have the fourth equation, you need to use constant relation. And that is how we use constant relation. This is the easiest way to find a constant relation. I'll tell you all the other methods, rate of change of, I'll take length, I'll tell you like how to analyze the, which string will slack, which will tighten this, like everything I'll tell you. But this shortest way, I told you, this is the shortest way. So now we'll use this. We'll solve this equation and we'll get the value of acceleration of 5g means b will find. Okay. Now see, from these two equations, if you add 2t cancel, 100 minus 50, that is 50 equal to 10a plus 5b. 5 gone, 10. So 10 equal to 2a plus b. Okay, fine. Now, if you solve these two equations, just multiply by 2 and then subtract it. Wait. So this is 2t minus 50 equal to 5b, and this t minus e minus 100 equal to 10c. So if you multiply by 2 and then subtract, this gone, 200 minus 50, that is 150, and 5b minus 20c. So divide by 5, 30 equal to b minus 4c. We have to find b now. So in this equation, you just have to put the value of c in terms of b. So value of c in terms of b. So this will be b minus 30 by 4. Let b as it is, and then value of 2a, that is 10 minus b equal to 0. Just solve it. So b minus 30 plus 8b minus 40 plus 4b equal to 0. So 12b plus 13b equal to 70. So b is 70 by 30. So this is the acceleration of 5 kg block. Bolo, understood or not? Tell me, you guys understood or not? So this is the easiest method. बोलो सब लोग, देवयानी, अर्चित, साइना।
यस सर, समझ गया।
ठीक है, इसको लिखो। अभी बहुत प्रैक्टिस करना पड़ेगा अपने को. We need to practice a lot. Then only you'll have confidence. Noted?
यस सर।
Everyone? Okay.
Sir, 1 minute, sir.
Okay.
Yes, sir. Done.
Now see, I'll tell you method number 2. How to find the constant motion. Randomly, you assume that suppose this block came down by x distance or displacement. This block goes up by some y displacement, and this block also goes by some z displacement. This is the R assumption. If I get value of x positive, it means our assumption is positive. If I get x as a negative, means our assumption is wrong. Now you see. Now you see one thing. See, this block goes up by Z. So because of that, every point of this string, see, string number 1, string 2, string 3, string 4, string 5. So if this block goes up by Z, because of that, this string will slack by Z. This string will slack by Z. So this string 1 will slack by Z. Now here, if this block goes by Y, goes up by Y, so this is the string that cannot slack. So of course pulley has to go Y up. So if pulley will go up, see, this is the pulley. If this block will go up by Y, so pulley will also go up by Y. So each point, this point and this point, both points will go up by Y. So because of this pulley is going up by Y, so because of this string will slack by Y. This string will also slack by Y because pulley, this part is also going up by Y. Now, now see one thing. So how total slack is how much? Z plus 2Y. String cannot remain as slack. Has to be taut. Something that like the movement of this block will tight this slack the string. Now see, this block is moving down. So because of that, this pulley will move down. So this point and this point both will move down. But this point cannot move down because this is fixed. So this part of displacement should happen on this path only. So this will go down by x, 2x. So this is the amount that by which string got slacked, and this is the amount by which string will be taut. It will tighten the string will be tightened up by this displacement. So this is 2x. So z plus 2y minus 2x equal to 0. This is displacement. Differentiate with respect to time. It will become z is displacement of this, suppose A, B, C. So velocity of A, this is velocity of B, this is velocity of C. Again differentiate with respect to time. Differentiate with respect to time. Again differentiate. It will be acceleration of A plus twice of acceleration of B minus twice of acceleration of C. So acceleration of A, we took A. See, kind of like the same relation you got. Kind of understood?
सर ये वर्क डन बाय टेंशन से भी कर सकते
नहीं वही वो तो मैं पहले कर दिया यहाँ से ना.
बस आपने टी डॉट ए किया टी डॉट पी किया टी डॉट एक्स भी कर सकते
नहीं वो ठीक है, वो वही चीज हुआ. मैं इसको दूसरे तरीके से भी स्लैक मेथड कैसे करते हैं कभी देखेगा तो बोलेगा ना कि सर ने पढ़ाया नहीं. तो मैं वो भी करके दिखाता हूँ. बट देखो ये थोड़ा सा टीडियस है, थोड़ा सा सोचना पड़ेगा, बट उतना मुश्किल नहीं है, प्रैक्टिस से आ जाता है. सबसे इजिएस्ट वे यही है जो मैं सबसे पहले बोल दिया. और उसके बाद तुमको एक्सलेशन में कांस्टेंट रिलेशन आ गया, फिर वही से तुम न्यूटन्स लॉ ऑफ सेकंड लॉ ऑफ मोशन लगाओगे एमबीटी बना करके. mg minus t, mg minus जो whatever net force equal to m into a. फिर you will get 4 equations and then you will solve it and you will get that. Understood? Everyone understood or not?
Yes, sir.
I give you one homework. You guys have to try and find the answer, and I will talk about this in next lecture. Or you can send me the solution. I will send the correct answer on group. See, this is the question that you have to try.
सर हो गया है
अरे तुम्हारा हो गया ना, इनका तो नहीं हुआ ना. तुमको तो मैंने पढ़ा दिया, मतलब डिस्कस कर लिया ना. हमने नोट कर लो क्वेश्चन को.